Welcome back. Right, in the last installment I went through the repair or replacement and checking of the power amp stage, which is the EL84 tube situated right there. If you recall, I replaced all the capacitors that fed into or from this tube. All of them were found to be way out of spec and leaky. These were replaced, and this was then ready to go further into the preamp stage, which is what has been done since. In the preamp stage, and that is this tube over here, I found exactly the same thing as with the power amp stage. All the capacitors were off, really off. Some of them were 3, 4, 5 times the original value, and I didn't even check for leakage. I know they'll be leaking. So those were replaced, and the resistors were checked one by one. Some of them in circuit, and some of them had to be desoldered at one point to measure them correctly. They were all found to be perfect in terms of value. Again, true to form with these radios. This particular one, this particular type of resistor, is particularly accurate. These guys really knew what they were doing back then. So all the capacitors in the preamp stage have been replaced, and I've gone back, and we'll see the schematic in a minute. I've gone back and checked every single point, every single component, every single connection from the output transformer back through the power amp and back through the preamp stage, all the way to the audio selector, input selector. Now what the selector does is, with these switches over here, you literally select which input you're going to choose. If you choose one of the radio bands, whether it be long wave, medium wave, or the FM band or short wave, that is the sound that then goes through into the preamp and power amp stage. But you can also choose what they call the TA button at the front, and that gives you an input into that gives you a connection to the phono input at the back here. That's the phono input, and what you would normally connect there would be a turntable. It can also be used as an input for a more modern version, which would be an MP3 player, in my case an iPhone, and that will give you the music coming through the power amp stage. So that's all been done. As you can see, around the volume control pot, you'd expect to find some of these coupling capacitors, and they were the ones that were replaced. Some of them here are part of the tone circuit. Over here there's mostly resistors. Some of those, that capacitor, that orange cap there, was found to be on spec. That's across the heater. And all the connections to that 9-pin tube connector have also been checked. That's the one going off to those exterior preset tone switches. And there we have it. It's been interesting, not difficult at all. Most of these capacitors have been quite easy to remove. What these guys tend to do in this particular brand, the Graetz, is they do wind these connector points quite rigorously. You can see there. They put the component through, bend it all the way back, and then solder. Now that's all fine for the reliability of the components and long-term stability, but it's a real bitch to unsolder. So what I've done is I cut off the component, and then after heating the connector, the tag, I take off the remaining bit of wire. But nothing's broken off. That's always a risk with these things. Some of these tags can be quite brittle. Nothing broke off, and everything was then replaced correctly. Some of those capacitors, as you can see there, have had a bit of sleeving put on just to avoid, they're quite lengthy. The wiring is quite lengthy, so in some cases I use sleeving just to avoid any undue short circuits. The bass knob was cleaned with contact cleaner. It's an open bass knob, as is the treble over there. It's an open, so it has collected a lot of grit and grime over the years, and it's always a good thing to clean them off properly. So far we have the audio circuit done. So what we have here now is the radio's on. I have selected the TA button, which is the gramophone input over there, and I've connected to the gramophone input over there a modern gramophone, which is a signal generator. I've got it at 500 Hertz, 100 millivolts peak to peak. The sound is coming through very clearly, doesn't seem to be at all distorted. The 100 millivolt peak to peak signal seems to be sufficient to drive it properly. That was a 500 millivolt peak to peak test, which seems to be a little high. I'm not quite sure what the output level of those gramophone outputs was, but I guess it would be in this range. The way to test it would be put in a signal and test it against, say, the FM reception. Put in an audio signal and test it against the FM reception, so that one can get an idea of just how high or low the input level is. But I would imagine any MP3 player output would be sufficiently high to give this a good sound. This is what we'd done in the first section. We checked the power supply, we checked the power tube all the way back through that treble pot, which was off spec, and we got to this point. Now this point was the input to the power amp, and the second stage then takes us further back and takes us into the preamp stage. And here we have it. We have the output from the preamp tube. This is the plate. The signal comes through this 100K resistor, and it comes in here, blends with the negative feedback signal from the output transformer, which allows us to control the treble. This resistor here is the biasing, or rather the plate resistor, for the plate of the preamp tube, which is an EABC 80. This is half of the output tube, the other half is over here. So we'll stick to this half for now. This configuration here on the heaters was at first a little bit odd. If you recall, the heaters here were simply connected to the 6.3 volt AC heater supply. Over here there's a bit of a strange situation. At first it was strange, and I understand now what they're doing. What they've done is they tried to quieten down this section because this can be a source of noise. On the AC line, they've quietened it down with a resistor here, bypass resistor across the heater, which is to try and reduce the RF, any noise that comes into this heater supply. There's a strange thing here which I still haven't figured out. I don't see anything on the radio. I don't have a full service manual for this radio, so it's a little bit difficult to figure out, but the service manual of a similar model indicates this as a ferrite core. I would imagine this is simply a ferrite core to ground, perhaps, again to serve as a bypass for RF or any noise coming in here. I can't imagine what else it's doing there, but anyway. This 20 meg is the grid resistor. This is basically just a triode, this part of the tube. The cathode is grounded, which means we have a fixed bias of sorts over here. Then the signal comes through this capacitor here, which is probably one of the most important caps in terms of noise and signal quality and bass response in the whole system. It is the one that comes from the power, the volume pot over here, goes along, it's shielded, and it goes through this capacitor. If you make this smaller, you literally cut down the bass response of the signal. And it comes then into the grid of this preamp tube. Coming back here, we have what seems originally to be quite a strange configuration. This is the volume pot. The volume pot, the wiper, is the one that takes a signal off to the preamp tube. One would expect the lower connection of the pot to be grounded. It is not, and we'll see why in a minute. We would then expect the signal coming in to be attenuated with the volume pot to be coming in at the top, and indeed it is. It comes in here through a shielded cable, grounded shielded cable, again through a 10 nanofarad capacitor, which, as you can see here, was 35. By the way, that one there was 128, and it's supposed to be 25. So this is a 10 nanofarad capacitor. Also, again, very important for the bass response. It comes from here and it comes to this switching. Now, this switching was all checked. What we're seeing here basically is that FM is connected. That's what they say in the spec on the data sheet anyway, on the schematic anyway. But it takes the signal. This is the one receiving the signal, so we've got to follow these around. What it's doing right now is it's taking the signal from this, which is the radio section. That part back there is the radio section. It is also connected here through a 2 meg resistor and 100K to ground to something called TBA. Now, I believe this is a recorder output. If you wanted to connect a recorder, you're getting your signal coming out here. The signal comes from here. Another signal coming into here is an option. So you basically have two main options here. One is the radio audio, whether you choose FM, shortwave, medium wave, what have you. That's selected elsewhere. And the other one is this TA, which is the gramophone input. So if you connect gramophone, you have this signal going from, this is the ground of the gramophone over here. That's grounded. The signal of the gramophone comes in, goes through this switch, F2, comes here, gets to G7, and this switch here switches up. In other words, this signal then gets routed through to your volume pot. And that's what we tested there with the signal generator. I wanted to make sure that the entire audio section is working fine. Then what we have around here, this whole contraption here, is basically a very clever way of achieving loudness, of achieving a good response at low volumes and compensating down at higher volumes. And it's a filter network which connects through to this bottom of the pot, which, as I said, is not at ground. Ground is here through this 100 ohm resistor. It's 100 ohms away. And it gives us this selectivity at lower volumes as the wiper comes down. These points are connected to fixed positions within the wiper of the volume pot. And it then goes off. There's these two 500Ks. It goes off we have the bass control over here. The bass control is also fed back to there and then to the bottom of the speaker. So this is all a pretty elaborate feedback system to achieve tone control. Very common with these old German sets. They then also go off here to this switching, which we'll see later. This is the preset switching for speech, solo, instrumental, and so on. So this is all to do with the tone controls. And it's pretty clever, pretty clever. In more modern sets, you just see a variation of either a Baxanol or even a simpler system of achieving treble cut and bass boost and so on. But these are pretty elaborate and they work very well. It gives these radios the traditional, I suppose you'd call it, bass response that they're famous for. Not only is it a tube effect, the tubes do give it a warmer sound and a fuller sound, but they also make the tone a lot more controllable. So, all this has been checked, all that has been checked, all these switches have been cleaned with contact cleaner, as has the bass control, as has the volume pot, as have the tube sockets. These tube sockets were pretty rusty. A bit of contact cleaner, a wire brush, very, very gently scrubbed on there. It all comes out shiny. You put some contact cleaner in the tube sockets. Don't overdo it, but a little bit of contact cleaner, put it in and out a few times, and it tends to make a heck of a difference, especially to crackle and noise and so on. It really does do away with all that. So, what's next? Let's see. What I want to do next is, I mean, this sounds a little bit simple, but I do want to paint the schematic uniformly, sort of from right to left, from the output to the input. And so I'll be checking all these sections here. This is the Magic Eye tube, which I know is working very, very well. And all this does is it connects the output signal, the strength of the output signal, which is this point here, basically this grid. There's another name for this, I can't remember it right now. It's basically an AVC voltage level. As you tune into a station, that level gets lower or higher, and it's an indication of the strength of the signal. It's usually a negative voltage. It's used to compensate the gain of the preceding AF stages, but we'll get into that in a later video. And it's also then fed through this resistor and directly from the power supply. So if you follow these two, there's a 500k resistor. It joins this one, which goes to the other emitter connection of the EM80. These two together come through this switch, through here, and to this point. And if you recall, this point was the B plus, just before the second or the third filter stage. Here's the second filter stage. So this is a B plus. This will be a high voltage, and that's normally how these Magic Eye tubes work. Strangely enough, this particular one came out as working quite brightly. They tend to burn out in time. This EM80 is not a particularly difficult one to find replacements for. Some of the others, the EM34, I believe it's the EM35, 34, are very expensive if you can find them. You can find used ones, various degrees of burn to them, but they'll still be in the 100 and something euro price range, which is a little bit expensive for a radio that perhaps costs as much as that to be, or less, in the state that I got it in. So that's it. I'm going to go backwards through this section, and ultimately we shall begin on the AF and RF stages back here. That's it for now.